at the, sorry, wrong thing. A couple of applications for the dot product, during which time we will also figure out how to take the dot product of Cartesian vectors. Okay. Previously, we just studied dot products. Oh, I've been saying dot product. I think what I'm meaning is the cross product for Cartesian vectors. Previously, we did geometric, all right, style vectors. All right, so what we're going to do here is we're going to take a look at this question here. First of all, we've got some three-dimensional points, okay? I'm not going to draw this because it's a tough thing to draw. It's tough to draw things in 3D. It gives, you end up with a lot of lines and things like that. And so what we're going to try and do is try to imagine all of this, all right? So we're going to determine the length of the altitude B in the triangle ABC, okay? Well, I will actually make one drawing. And so here's my triangle A, B, C, okay? And I'm going to put B here, A there, and C there. The altitude B is the altitude that goes through B, and essentially what we're trying to do is determine the length of this guy, okay? And as it turns out, one of the best ways to actually get this done is to figure out the area of this triangle, all right? So we know that the area of the triangle is 1/2 base times height, all right? And, well, it's 1/2. The base, it could be the magnitude of the AC vector times the height, which is B, right? And sorry, I used the letter B here as well, all right? But this letter B and this letter B are different, okay? In here, I just kind of used the generic area of a triangle is 1/2 base times height, whereas B is this here. The reason why I'm calling it B is because it's called B in the question, okay? And so, as a result, basically the area of the triangle is 1/2 magnitude of AC vector times B. And if I can figure out all of these things here, basically I can figure out what B is, all right? Well, as it turns out, actually, the area of a triangle is a new formula, right? The area of a triangle is A cross B, okay, divided by 2, where A and B are two vectors in that triangle, all right? And so, or maybe I'll call it, just to have a little bit few less A's and B's, all right? I'm going to go ahead and call this N dot M, all right? Just for ease here. So it's, oh shoot, that was supposed to be an N. I don't even want to use N because that kind of connotates normal. And so perhaps I'll use, M cross P, where the M vector is maybe, I guess, this one, and the P vector is any other vector in the triangle. And so we'll call this the P vector, okay? And so therefore the P vector is AC, and the M vector is BC. All right. So this is now 1/2 magnitude of AC and B, right? So essentially, and this is over 2, the 1/2s cancel, all right? The 1/2s cancel, that half and that half. And essentially, M is BC, so it's the BC vector crossed with the, the AC vector should equal over the magnitude of AC should equal B, right? And this is basically the answer to this question. All right. So determine the length of the altitude B in the triangle. That's what we're doing. All right. This is how I will determine it. Just quickly going over that again. The area of a triangle is 1/2 base of the triangle, height of the triangle. So therefore it's 1/2 base of the triangle. I've called it AC. Height of the triangle, I've called it B, which is what we're looking for. All right. And so therefore it's 1/2. The area of the triangle is 1/2 ACB. And then this is now new. A new formula. The area of a triangle is the cross product of 2 of its sides divided by 2. Okay? So the 2 sides have to be in vector form. So now one side I've called BC and the other side I've called AC, right? And so basically the answer B is BC cross AC over magnitude of AC. All right. Oh, and by the way, we also need magnitudes here. Sorry, my original formula was supposed to have a magnitude symbols there. Those are actually not magnitudes. Yeah, that's magnitude. That's a magnitude. All right. So now we basically need to do a lot of stuff here. Okay. Now, in order to get these things, I first need vector BC. Well, we remember from the past the vector between 2 points. You would take the second point, the second coordinate, and subtract the first. And so I'm going to go basically here 4 minus 3. So I'm going to get a 1. And then for the the y component of this vector, it's 1 minus a negative 2. So 1 plus 2, or 3. Okay, and then it's negative 2 minus 0. So it's actually just a negative 2. Okay. Yeah, there we go. Negative 2. And then let's see. So that's it. I also need vector AC. All right. So again, that's going to be 4 minus a negative 1, or 4 plus 1, which is 5. Then it's going to be 1 minus 0, or 1. And then it's going to be a negative 2 minus 1, or a negative 3. Okay. So these are now my 2 working vectors. Hopefully that was a 5, I believe. And now, basically, I need the magnitude of AC. So magnitude of AC is going to be the square root of 5 squared plus 1 squared plus negative 3 squared, which is equal to the square root of 25, 26, is 26, 36, 35. Square root of 35, okay? These square root symbols got a bit big, so this was supposed to be the square root of 35. That's magnitude of AC, so that apparently goes here, okay? And now, only thing left I need is BC cross AC. That's going to be a vector. Remember that if you take the cross product of two vectors, you get a vector. And then I'm going to need the magnitude of BC cross AC. And so that's just going to be the square root of a vector, or of these components here, here, and here will go there, there, and there, okay, when I find those, all right? So now, basically, once I get that answer, that will go right here, all right? Now, so that only leaves one thing, is how do I take the cross product of two things, what are these guys called? Vectors, two vectors, given the fact that they are in Cartesian format. This is now new, all right? Oops, I erased all that stuff. This is A, C, sorry, no, this was a B. This was a B. I didn't want to erase that. Okay. So now in this little area, right in this area here, I will take my cross product, okay? So B, C cross A, C, all right? This is how I'm going to do this. You do X, Y, Z, X, Y, Z, all right? This is, there's all sorts of different techniques here. And now what you do is you write the first vector in the cross product, which is BC. I'm going to write it 1, 3, negative 2, 1, 3, negative 2. Okay, that's basically the components for the BC vector. Okay. Then you take the second vector and you write it. So 5, 1, negative 3, 5, 1, and negative 3, right? That is, oops, that was the wrong thing, the wrong one there. That's supposed to be, I'm supposed to be getting this. That is basically the AC vector, okay? And now, basically, what you end up doing here is trying to, well, there's a procedure here, and the procedure basically goes like this: you take the to get the X component basically here, all right? You actually sort of make a cross like this, okay? And you have to start up here and go down like that, okay? And then the other one would be like this, all right? And what you do is you take this first one here, this first one, and you write these values down, 3 times a negative 3. And you subtract 1 times a negative 2. So that would be 3 times a negative 3, 1 times a negative 2. All right? And that's to get the X components. All right? Now, I'll write it like that. To get the Y components, it's actually similar, but you start with the here going from the y. So you go -2 times 5 minus -3 times 1. All right, and maybe you were seeing that's to get the y components. So to see how the y components, basically to get the y components, you use the z and the x values. Notice that. And then to get the x component, notice I use the y's and the z's here. And then likewise, to get the z components, I'm actually going to go this times this minus that times that. All right, so it's 1 times 1 minus 5 times 3. This is going to be your x component, your y component, and your z component. And it's that easy. That is actually the same thing as doing the cross product. All right. Another way of getting the cross product would be to find the magnitude of each of these, find the angle between them, and stick it into the magnitude times magnitude sine of the angle between them formula. Okay? That would give you only the magnitude of the cross product. But since that's what you're looking for, it actually could be a little bit of a faster method. But I wanted to just go ahead and find the entire cross product. So this is now 9 plus 2, or 11. Oh, no, sorry, it's -9. Sorry, I almost made a mistake there. So it's -9 plus 2, so I'm getting a -7. And then I've got a -10 plus 3, so that's 7 as well, negative. And then I've got a 1 times 1 minus 15 here, or 1 minus 15, it's a negative 14. Interesting cross product there, right? -7, -7, and -14. All right. And so there it is. -7, -7, and -14. And basically, what I do is I stick those guys in there and I figure out their magnitude. Hang on, I think the cat needs to be let outside. Okay, yeah, cat had to go out. All right, so we're back, and where are we? We are figuring out this, the magnitude of BC cross AC. BC is here, AC is here. The cross product is this thing right in here. Make sure you look at that a few times so you can make sure you can do cross products of Cartesian vectors. And now we're just figuring out this magnitude. So it looks like to be a pretty big number. Got out my calculator. It's going to be 49 plus 49, so 98, because the square, 7 squared and 7 squared, and then 14 squared. I don't remember that one. That's 196 plus 98 plus 98. Oops, I did times 98. 98 plus 196, giving me 294, the root of 294. All right. So that's equal to, I'll write that here, the root of 294, right? That's what, the cross product, the magnitude of the cross. So that's the root of 294, okay? And so in the end, the whole thing is the square root of 294 over 35. That's the length of B, right? And I'm dying to figure out what that number is. 35 And then I'm going to take the square root of that thing. Oh, it's actually kind of a small number. And so I'm going to do square root of the answer. 8, so about 3 almost. Excuse me, 2.9. So about 2.9. That's the length of B, right? Whereas the area of the triangle ABC, we actually inadvertently already solved that question. So part II, this is part I, okay? Part II is essentially, remember, the area of a triangle is, you can take the cross product BC cross AC divided by the magnitude of the cross product divided by 2. And so therefore it is going to be basically the square root of 294 over 2. And that's the area of the triangle. All right. That's the cross product and a few of its applications. Okay. Another quick thing is, if you have a parallelogram, right, it's got A, B, C, D, right? If I take AB cross CD, sorry, AD, which would be this vector cross with that vector, and I figure out its magnitude without dividing by 2, then I've got the area of a parallelogram formula, okay? Because if I were to divide by 2, I would have a triangle, right? But I am going to leave it by not dividing by 2, and I have a parallelogram. So just be aware, the area of a parallelogram formula is this. And then if it were a triangle, it's the same thing, but divided by 2. All right? Just a little extra bit of info there. All right.